Hello learners, I am Dr. Neha Parsekar, Assistant Professor in Chemistry at Ganpat Parsekar College of Education. I welcome you all for this Chemistry MCQ Solver course. This module will be based on solving problems in chemical kinetics. We will begin with the first question. If the half-life is directly proportional to 1 upon A, that is concentration A, then the order of the reaction should be 4 options. The first one, 0 order, first order, second order, pseudo order. To solve this problem, one should know the dependence of half-life on the initial concentration. As you can see here, it is independent for the first order reaction. In case of second order reaction, the half-life is directly proportional to 1 upon the concentration of the reactant. For the third order reaction, you see that the half-life is proportional to 1 upon square root of the concentration term. And hence, option number C, that is the second order, is the correct option. Question number 2. The rate of a chemical reaction doubles for every 10 degree rise in temperature. If the temperature is raised by 50 degrees Celsius, the rate of the reaction increases by about 64 times, 10 times, 32 times, 24 times. To solve this problem, we start. For every 10 degree rise in temperature, the rate is doubled. That is what is given in the problem. Thus, here the temperature coefficient is 2. Let us consider the initial rate to be R1. Then the new rate R2 which is obtained is equal to R1 times 2 raised to the temperature difference divided by 10. Temperature is increased by 50 degrees Celsius. Hence, the rate increases by R2 is equal to R1 multiplied by 2 raised to 50 divided by 10. This will give you 2 raised to 5 times R1. 2 raised to 5 is 32. The option number B, that is 32 times, is the correct option. Moving on to question number 3. The following reactions A plus B giving you C plus D. Doubling the concentration of both the reactants increases the rate of the reaction by 8 times, and doubling the concentration of only B simply doubles the rate of the reaction. The rate law is given as, options are given. Solution, rate in general can be written as R is equal to K times A raised to X multiplied by B raised to Y. For the first equation, that is for the first sentence, rate increases by 8 times, and hence it is written as 8R is equal to K times the concentration of both the reactants is doubled. That is the reason 2A raised to X and 2B raised to Y is written. For the second case, the rate is doubled by only doubling the concentration of reactant B, and hence the equation becomes 2R is equal to K A raised to X times 2B raised to Y. Dividing the equation 2 by equation 3 will give 2 raised to X is equal to 4. 4 can be written as 2 raised to 2, and hence X is equal to 2. Dividing equation 3 by equation 1 will give us 2 is equal to 2 raised to Y. Here Y will be equal to 1. Hence the rate is equal to K times A raised to concentration of A raised to 2 and concentration of B raised to unity. Question number 4. Decomposition of H2O2, that is hydrogen peroxide, to form 2 water molecules and oxygen molecule is a dash order reaction. Options given are 0 order, first order, second order and pseudo order. Solution. A few examples of the first order reactions are given here. As you can see, H2O2 giving you 2H2O plus oxygen is an example of a first order reaction. Option number B, stating first order, is the correct option. Question number 5. A catalyst increases the rate of a reaction because it decreases the heat of the reaction, it decreases the order of the reaction, it provides the necessary energy to the colloiding molecules to cross the energy barrier, it provides a different path of lower activation energy. A catalyst increases the rate of a reaction in both forward and backward direction, by providing an alternate pathway with lower activation energy. Therefore, the catalyst increases the rate of a reaction by lowering the activation energy. That is option number D, saying it provides a different path of lower activation energy, is the correct answer for this question. Question number 6. In a first order reaction, half of the reactant is decomposed in 1000 seconds. How long will it be until 1/3 of the reactant is left? We are provided with 4 options. As you can see in the question, a first order reaction, that means the order of the reaction is mentioned and the reaction is completed in half time, that is 50% of the reaction is completed here. Solution. First, we will find out the K value using the following equation. K is equal to 0.693 divided by T half. Next, to find out the T value, we will use the formula for the first order rate constant, that is K is equal to 2.303 divided by T log of A upon A minus X. A is equal to 1, X is equal to 2 by 3, A minus X is equal to 1 by 3. Substituting these values, we get the value of T to be 1585.51 seconds. That is option number B. Question 7. 75% of a reaction of a first order was completed in 32 minutes. When was it half completed? The 4 options are 32 minutes, 10 minutes, 16 minutes and 26 minutes. Solution. K is equal to 2.303 divided by T log of A minus A upon A minus X. Again, here we are talking in terms of percentages. So, A is taken as 100, X is 75 and A minus X, that is what is remaining into the solution, that is what is unreacted, is 25%. Substituting the values in the rate law equation, K is equal to 2.303 divided by 32 log of 100 upon 25. We arrived at the value 0.0433 per minute as the K value. Using this value, we find out the T half for the reaction, which is 16 minutes. Option number C, that is 16 minutes, is the correct option. Question number 8. The activation energy of a reaction with the help of a plot of ln of K versus 1 by T is given by, the 4 options are given. Solution. The Arrhenius equation is ln K is equal to ln A minus EA upon RT. Thus, the activation energy of a reaction can be determined from the slope of the graph ln K versus 1 by T. Here, the slope is equal to minus EA divided by R, and hence activation energy EA is given as minus slope multiplied by R. Option D, that is minus slope multiplied by R, is the correct option for this question. Thank you.